Hello everybody and welcome to part 8 of this animation series. This time I would like to rig a car. You see I have a simple car model here. The body is in its own mesh and each of the wheels are in their own meshes as well, and you see here the revolve channel modifier, which is used to make these wheels rotate according to the position of the main locator. So let's press O to get the visibility options. Make sure we see the locators. Yes. And this is the only thing which is rigged so far. I could have done it the way I did in my previous video, but I wanted to show another way as well. So the only thing which works here is the wheels turn, but they do not follow the surface. You see, they just sink in or fly on top of it. So let's start with this. I enlarge this part here, get rid of the body, and first I need 4 locators. So 1, 2, 3, 4. I select the first one, shift select this wheel here, go to setup and match and align item position. Then I select the second one, shift select this wheel, item position, third one, shift select this wheel, item position, and last one, shift select this one and item position. Now I can select all these locators, make sure nothing else is selected, and Control G for a new group and call this wheel locators and bring it to the main locator here. I think I make this another color, red, why not? So we can immediately see to where everything is parented. Now next I don't need to see the wheels, but I need to see the plane. So I, in item mode, select this locator, shift select the plane, go to modifiers, intersect surface, do the same here, intersect, same here, intersect, and the last one here, intersect. And now we have got 4 new locators which we can select and put in a new group. Control G. So these are the surface locators, and I also parent these to the main locator. Next we need the wheels, but we don't need to see the wheel locators. Then I can select this wheel and this locator and make a position constraint. Make sure compensation is on. So position constraint, this one, shift click this one, position, this one, shift click this one, position constraint, and the last one here. Now we have all these position constraints, and as you know from previous videos, this can be used to add output options and disable X and Z movements. So next one, output options 0, 0. Next output options 0, 0. And last one, output options 0 and 0 again. Now we should follow the terrain. With this, let's check. Yes, that looks good. Okay, now the wheels follow the terrain, but the body is always the same position. Now we need to adjust this so the body follows the wheel. So we need to know the Z and X rotations or the roll and pitch. So let's do that. First I go and hide the body. I hide the wheels. And we need 4 new locators. So 1, 2, 3, 4. And then I select this one, shift click this locator and go to item position. Next one, shift click item position. Next one, shift click item position. I got used to a certain sequence of selecting things. I think it is less error prone if we do it this way, but this might only be me. So item position. Now we have 4 locators which are exactly placed at the same spots as our surface locator, so we can move them away. So I move them up by 3 meters and 0 the positions, so everything is 0, and I call these locators Control G, make another group and call them measurement locators. Okay, and parent it to our main locator. Now I hide the plane and I think I give these another shape, just the top one, so we get not confused, or I do not get confused. So display, locator shape, custom, I want to replace, make a pyramid, solid along the Y, and make it 300 by minus 500 by 300 millimeters, and give it another color, so blue. Good. Now we do not get problems by selecting the wrong ones. Okay, let's go back to our schematic view, and we need a new one. So I click on this icon here and say this is measurements, and make this one active and click OK here. We need a bit more space down here. So, okay, to find out about roll and pitch of our vehicle, we need to measure these angles here. This is the front axle, the back axle, this is the left side, and this is the right side. Or this could be the right, left and this could be the right, doesn't matter. I tried several different things, and only after I looked closer at the car rigs which are available from the Luxology site, the link is in the comments, I didn't understand it, but I came to the conclusion that the right way to go forward is by measuring the angles. But first, what do we want to achieve? I bring in the body, and actually we want as a final product to see the X and Z rotation. Sorry, that wasn't a good idea. So I click outside here to select channels and maybe the Y position. But I show you an easier way, but I will also explain how we can do it in the schematic view. Anyway, let's find these channels. So here is the Y position, and it has automatically taken all of them. So this is what we want: rotation X, rotation Z, and position Y. And I think I quickly go and show OK where my centers are. The centers of the wheel are right here on the inside, in the middle, and the center of the body is here in the middle of the body, on the bottom, so we can rotate it around the X, Ctrl Z, and we can rotate it around here depending on the terrain. So let's undo this, let's hide the body and go back to here, and first I select all these, right click, select everything, deselect the master, the main locator, and add selected to our schematic view. And we see we have the world position here in these ones, the surface locators, and we don't have it for the blue ones. So W, no, I take this one out. Sorry, like so. So I can select all of them. We have 8, 10, 11 and 12. Let's enlarge this, and here we have 8 world position. It will automatically be docked here. Then we have 10 world position. Then we have 12 world position. And finally we have 11 world position. Now we can arrange these. So 8 comes here, 10 comes here, 12, no, 11 comes here. Okay, now we need to add a channel modifier, and what we are looking for is a measure modifier and measure angle. As I said, we need 4 of them to measure the angle of the front axle, of the back axle, of the left side and the right side. So maybe it makes sense we rename this. So this is front, then I take a new one, measure angle, this is back, bring it to here, add a new one, measure angle left, and a last one, measure angle right. Okay, now we have everything. We now just need to wire it up. So it will be, let me see the visibility options. I don't want to have all centers, just so it will be very clear what the position from is, the position to A and position to B as soon as I have rigged up the first one. So I start for the front and select this locator and wire it to the position from. Then I select this one, and the good thing is they get highlighted, so we know this is the position to A. We could also use the other one, doesn't matter which sequence. I just try to stay consistent. Now I need this last one, which is here. And if I click on this now, you see it measures the angle, and the point it measures it from is the position from, and this is what we have to select first. So let's go to the back. So this one is the first, select it. This is the second. This one is the third. And now we do the left side. This one, this one, and this one. And you see now it measures from front to back. And finally the right side, this here, then this one, and the last one here. Now we have all the measurements we need for pitch and roll, and if I run the animation now, you see the numbers change and these angles are measured, and we can use them for our next thing to do. So first of all, we only need the average of the front and the back and the average between left and right for our rotations. So we add a math modifier, basic math average, make another one, basic math average, and we can put this to here and wire it in like so, and wire this in like so. And if we select it and go to the channel display, you see we have value A, B, and the result is 90 degrees. And if I bring in the body now and plug in any of these, it does exactly what we have to expect. It rotates it by 90 degrees. So we need to add a relation. So first we can select this and add another math, and I say subtract modifier. It puts it automatically in the middle, and we can say here subtract 90 from this, and then the result will be 0 and all is good, or not. So let's run the animation, and you see it is doing what we expect, just to the wrong side. So let's go back, and what we can do to fix this is add another math modifier, multiply here, and multiply this value which comes out of the part here by -1. And now when we run the animation, it works. So that's one way of doing it, but I show you another way which is a bit more elegant than what I did, but I wanted to do it to show there are different ways to do it. So what we can do is to add a new type of modifier, namely a channel relationship modifier. Relationship means the relation between one number and another number. So we can wire this in, and then wire this in here, and when I click this I get this window here, and I think the easiest way is to use the graph editor, and when you want to type in here 90, it doesn't work. But we can just move this key a little bit and then the fields get editable. So 90 here, let's have a look where this is. Here is our frame 90, or our 90 degrees. And now we can tell what the difference is. So I middle click here and correct this and say 100, and I know this is a positive value, so I say if the input is 100 degrees, then the output must be 10 degrees. We could use 95 and 5 or 200 and 100, or doesn't really matter. What we also have to do is to change the constant from constant to linear, and the same here. Now we can close this, and if I take this away and run the animation, you see it is nicely following our terrain. So this is actually it. Let's bring in the wheels and wire in this Z rotation, and I'm in camera view. The camera is attached or is parented to the main locator. I press O to not show the locators. Now let's drive. that looks already quite nice. There is only one thing which is left to do. This is the Y value. What we could do is we could add, for example, measure distance and then measure the distance. Let me bring in the locators again, between the blue ones and the surface locators, and then calculate the average. For this we would need, because we have 4 averages, we would use a math multiple average, and then we could input 4 values all into here and calculate this and use a relationship and finally calculate the Y position. That's quite a lot of work, and I show you a much easier way to do it. So I backspace delete these, go back to my vehicle here and select the ground plane, Control copy, N for a new mesh, Control V, W, bring it further down a bit, doesn't matter how much, go to the model tab quickly and press the R key and bring this down to anything between 40 and 50%. It depends how much you want to go the wheels towards the fenders. Let's go back to the setup, and then we need a new locator, and I shift select the car body and go to setup, item position, and position it to the body. So I rename this to body locator and parent it to the main locator. Now with this locator still selected, I shift click on the second plane I made and say modifiers intersect surface. Then I click on the body and on this new surface locator, and with compensation on I make a position constraint. Now if I run the animation, you see it is behaving weird. We could fix this as we did with the wheels, but I would also show you another way of doing it. If I select this locator here, I get this intersect, and what I can do here, I can go from closest, which is the default, to ray. Now it actually projects a beam going straight down and not to the nearest vertex or nearest whatsoever. We want to have this around the Y, and we must click negative. We could have also done this for the wheels instead of the position constraint, but I wanted to show you both possibilities. This one works equally well. Now let's play this animation and let's have a look how this has worked out. I must say this looks pretty realistic and was not very complicated to do. So I go and hide the locators and go a bit closer, and we can watch this it looks really quite nice. What we also could do is animate the front wheels with the steering wheel, but this should be easy to do with all the previous tutorials I made, and also with the channel relationship modifier. There is one thing I would like to do, namely, we don't need this mesh to see. If I look at a real car, if it goes through such big bumps, then the wheels do not stay precisely vertical as these ones do. They have a slight rotation, and I tried to do this and I didn't succeed. Maybe in one of the next videos, because if I rotate this in item mode, E, just slightly, then if I play the animation, you see the wheel starts wiggling, which is not what I want and which is something I don't know how to get around. If someone of you has an idea, then please let me know. The other thing which I don't know how to do is this W key motion here in the y-axis seems to be limited. At a certain point the wheel just stops going upwards, and this leads to the effect that I have when I have a very steep slope, the car just drives through the surface. So again, if someone knows how to get around this, I would be grateful, and I think all the other ones too. Well, thanks for watching. I hope you have enjoyed it. I hope it's helpful. Take care and have fun modeling with Modo. See you some other time. Bye bye.